So I think it's time to add a little bit more functionality to our layer 2 switch. Because I want to be able to do a show interfaces command as well. I want to get some statistics about how many frames and bytes were forwarded in and out of each interface of this layer 2 switch. I need a data construct where I can store multiple data points for each interface. So I will create a new dictionary of interfaces, and inside of that I'll have keys and values. So I'll just use the interface names as keys, and then the value will be yet another dictionary. So inside of this dictionary I can then have a new set of keys and values where I can store data. So this is called a nested dictionary. It's a dictionary of dictionaries. So my outer data type is a dictionary, then I have a string as a key, and then the value is yet another dictionary. I can keep doing that for as many times as I like. There's no limit to how deep you can make your data constructs in Python. But right now I'll just stay with these 2 levels. So this is for one interface. I'll just copy and paste that to create the next interface and all the others as well. So I'll just collapse most of the inner dictionaries here to make it easier to see what's going on. So all of them are identical to Ethernet 0/8. So then what I want to do is that every time I'm receiving a frame, I should record that for the ingress port, and every time I'm forwarding a frame, I should record it on the egress port. So let's do that as the very first thing right after we have received it. So my interface counters are stored inside of the variable named interfaces. And inside of that, I can use the ingress port as the key. Let's say that this was Ethernet 0/8. Then that takes me into this dictionary. And then I can add another level of square brackets here to define yet another key. And this would be in_frames. Which initially was set to the number 0. I need to increment that by 1. So either I could just assign it a completely new value. So that would be equal to 1 plus and then the same value. Then it would increment every time that my incoming frame was invoked. There's a shorthand to this in Python, which I'll recommend that you use instead because it's a bit more readable. That's the plus equals to operator. So this will just add the value on the right-hand side of the operator into the existing value. So it's still incrementing, but just with a simpler syntax. So that was for incoming frames. Every time I forward a frame, I want to do the same thing. So I'm accessing the interfaces of the egress port this time. That's the parameter I'm receiving here in my function. And then I should record that in the out frames and increment that by 1. So let's keep it at that for now. We'll count bytes a little bit later on. But for now, I think that I should implement another show command down here. I should implement a show interfaces command. This is where we see statistics for the number of frames and bytes that were sent on the port. Let's print out an iOS comment right here that this is for the show interfaces output. And then I'm going to loop through the dictionary of interfaces. And for each of those items, I'll access the counters in here. So we know how to do a for loop for a dictionary. We have keys and values. The keys in this case would be the interface name. And the values will be equivalent of a data structure like this. So that would be a dictionary of counters. So I'll just give that a new name here. And loop through the items of that dictionary. The output would simply be the interface name, followed by followed by the counters value for in frames and out frames. Okay, so let's just invoke that right here at the bottom of the script. Show interfaces. I'll scroll back up so you can see the logic and the structure over here. And I'll run it and I get an error. So I made a mistake here. So the variable I'm referencing here is named counter, and I actually named it counters up here. So the for loop is defining that new variable and assigning it a temporary value, which is relevant only for that iteration. So let me just use the exact same variable name here. That should help. So there are the numbers. Let me just give it some context here. And try again. There we are. So this is actually counting all the frames that are going in and out of these interfaces. So that's pretty cool, right? If we look closely to the two lines that I just created, 94 and 95, I have my F strings right here. They start with double quotes. And to access a value inside of a dictionary, I need to provide square brackets and then the key string inside of it. In earlier versions of Python, you couldn't use double quotes in there as it would result in an error. But in Python 3.13, which I'm running here, it's not a problem. But you will see a lot of Python code out there that alternates between single quotes and double quotes. So that is still best practice to use a different kind of quotation inside of your placeholders for data that is extracted from a dictionary using string keys. So double quotes on the outside and single quotes on the inside. So let's just finalize the logic here by also counting the number of bytes. To do that, we need to specify on the incoming frame exactly how many bytes were received. So I have another version of all of these frames that are coming in, which have an additional parameter out here at the end. So these are the number of bytes in the payload. So that also means that I need to modify my incoming frame function to actually process and pass this parameter along. So let's go to the incoming frame and modify the signature of the function like this. And then I'll record that ingress port, but this time for the input bytes, I'll increment that by the size. So to record that in the output direction, I also need to pass along the size to my forward frame and float frame functions. I'll just add that as a new parameter. And modify the function signature to allow this new value and pass it along between the functions. So then I can finally record the out bytes by incrementing that by the number that is present inside of the size parameter. So let's see if that works. Okay, no errors so far. Let's just add something to the output as well to make it look like a show interfaces command from a Cisco device. Counters in bytes. So that looks great, right? So now we have recorded the number of frames, the number of bytes in both directions, and we can see the MAC address table of this layer 2 device, and we can see a lot of debugging information up here about exactly which frames were received and how our emulated layer 2 switch handled those frames. So that means that we covered nested dictionaries and calculations as well. The last thing I want to introduce you to here is string slicing. And let's say that we wanted our output from the show MAC address table to show up slightly different. So you know that on Cisco devices, we always have long and short names for the ports. So Ethernet 0/1 could also be named just ETH 0/1. And if it was 10 gigabit Ethernet, it could be TE 0/1 and so on. It's always valid just to use only the first 3 characters of a port type and then the port numbers after that. So I just want to show you how we could change the output of our table right here. And to do that, let me just first disable the show interfaces by turning this into a comment with a hashtag. So our MAC address table is the only thing that's displayed here at the bottom. And then find the place in my code where I do my show MAC address table. Inside of that loop, I want to figure out what would the short name be for my interface name. So this one. Let me just go into the Python REBL again. And assign an Ethernet name here. If I'm just printing out this interface name, then I get the whole thing. But what I can do is that I can actually treat a string like a list and that get only a single character. So if I'm looking at position 0, that would be the first letter in my string. Okay, and so on. So I can access one character at a time like that. I can also access a range. So I do that by using 2 numbers with a colon in between. So this means from position 0 up until position 3. So that gives me 3 characters back. So it stops right before it reaches the limit right here. So I can also take something right in the middle. So starting from character 5 up until 7, for instance, and it'll give me a different part of the string. So whenever you start with 0, you can also just leave it out like this, and it'll show you the same thing. Colon 3 will just be the first 3 characters of a string. So that looks like something that we can use. All right, then I want the last part of the string as well. And remember that lists are circular, so we can go the other direction as well. So I can also ask for character -2, for instance, which is a slash, character -1, which is a 1, character -3, which is a 0. So character -3 is the third last character. So I want to get from that character and then to the end of the string. And I can do that by adding a colon right here, which means that the string slicing will go from the third last character and then up until the end of the string, and it gives me exactly what I need. So then I can actually go ahead and combine these two. To get a short version of the same interface name. So that's pretty neat. Let's implement that in the code over here. Short name equals to, let me just copy what I created here. And then use that short name inside of my output. I'll exit out of the Python REBL and try again. And now I see my short interface names right here. And now you've also learned about string slicing. It's very useful in those cases where you know the structure of your strings, so you can just take different parts of it and reuse it in another context. So in that way, we quickly created more than 100 lines of code. Some of it is kind of repetitive with these different interface counters right here, as well as the incoming frames that I'm generating. But all of the forwarding logic is inside of my functions here, and I can reuse those multiple times. So that should be your takeaway here, that if you ever feel like you are repeating yourself in your code, then maybe you should take a look at creating a function instead of just writing the code at the root of the Python module.